Okay, here we are, 60 Water Street. This is the federated building that I'm in, 160 Water Street. Kassay is got a great location right around here in the back. We have these doors here. There's our trailer, and here is our door here. Okay, walking into the Kassay office here. My desk, conference room area. Back here is my Marie's office. Just pan around. Okay. Hey Marie, I want to show one thing that Marie's the administrator, and I want to show one thing that I failed to mention yesterday. So the Ram 2000 G2 has something that's very special that was designed so that it could be an open path analyzer, an extractive analyzer, and in the open path it can go active or passive. All of that is all on the same bench. So if you open up the cabinet here, for QA/QC, your QA/QC cell, actually 4 bolts, it goes right down in here, and you connect the 2 swedge locks, and you can flow gases in. It actually sits right in that compartment there. And if you want to do extractive monitoring, this system can run with multi-pass gas cells. This is a 10-meter cell here, and it's the same deal. It picks off the IR energy, and basically the energy flows multi-passes. In this case, it's 40 passes up and down. You can take this plate off, shut the lid down, and it runs as a full-time extractive gas analyzer. So the multi-passes in these give you better sensitivity, and something for you guys to consider, because in the Bay Area there is one refinery that is actually going to do their fence line monitoring with FTIR extractive, which we think we are going to be the supply vendor for. As far as the active versus passive, there's one other thing here. You have the active setup with the K508 sitting over here. If you want to run passive, where you have a remote source out there, and that's how we run at Phillips 66. We have a heated remote source. You just take the whole K508 4 bolts, pick up, remove the IR source, and place it back down, and that's it. It's that simple. 4 bolts, and slide it over so you can run passive. It's a very simple system. And we'll go into the lab and we'll see what's going on in there. This is the Kassay lab, and over here we kind of have, that's Tyler working down there on one of the systems. Over here we kind of have our shipping and receiving and some of the lease things that we send out. Over here we just got a new set of our telescope tubes in, 10 of them, and 4 of those will be prepared for torrents. All of our new part assemblies are here. Our lids, they're all metal parts that are fabricated right here by Temple Metal Services, which is about a half-mile away. Our heater assembly, hinges. Then over here we have some of our machine parts. All the assemblies that we had that include the mirror fixtures and special adjustment features, all those are machined. Some of them are machined right here in Hamburg, PA, which is the next town above Reading. Some of them are machined at TMI down in Albuquerque, New Mexico. Our cable assemblies. One of the things that I didn't mention before, the mil spec. Okay, you notice that our cable has AC externally wrapped, DC inside shielded, and then we have gold pin connectors. This is a mil spec. Triple redundancy on the 12-volt power supply, double redundancy on the 5-volt power supply. That really helps us keep our detector very isolated from all the noise that can possibly impact it. Okay, coming over here, these are the 4 systems that we're putting together for torrents. Basically, these chassis are designed to be very, very rigid and stiff. We went through many iterations of deformation process. It's not just a box, it's a box designed for an open path FTIR. I don't know if you can see, but all these parts are machined out. All the ribs are specially designed so that they can be provide rigidity in the appropriate spots, especially when you're sitting on a tripod head or a positioner head. One of the things we learned in the past was that chassis can deform, and as soon as things deform, optical systems don't work. Over here, we have all of our spare parts and miscellaneous things. We have two isolated optics cables, and these isolated optics cables, they have pneumatic systems underneath. They can be isolated so that things can be perfectly stable. We can screw fixtures into them. Each one of these weighs 2,000 pounds. They're excellent cables. Over here we have a new product that is an extractive system that will run. It's actually a little bit of a less cost model version. And here's the gas cell. The interferometer sits right here. Detector assembly is designed so that it's a standalone system that can run unattended, and the orientation is such so it can hang on a wall or a pole or something like that. It's a standalone continuous extractive system. Coming over here, I want to tell you the latest addition to Kassay is our retroreflector manufacturing assembly. This retroreflector assembly holds 2 patents, which is about how the orientation of the cubes are put together. And of course, corner cubes being one of the critical components of any open-path FTIR system, we felt that we had to be able to have our own corner cube assembly so that 1, we could control supply, and 2, we can control quality. A third thing that we're looking into as well is we can change the different coatings. So the way this works is, I'll just turn it on really quick and show you. So basically, you can build 15 cubes at a time, and you put a flat in each one of these locations. Now, right now, we have this imaging camera that stares up into it, and this turns down, and once you have the flats in, we have a pump. I'm not going to turn the pump on, because when the pump is on, it makes a lot of noise. But the vacuum pump holds the flat into the fixture. You turn the fixture over, and then your cube is facing down. When it's facing down, you get an image on the screen that looks like this. And what this image does is it allows you to count the fringes on the cube. So you can see how well the cube is put together. Now, some cubes have an arc accuracy of like 20, and other cubes could have an arc accuracy of 1. The lower the number, the better the system cube is. So the cubes that we're supplying right now to for this project that we bid are Newport. It's called a replicated cube. It's actually solid aluminum, and then it's coated. And we've had very good luck with these. The one thing that we have done is we have worked with Newport to come out with a new coating, which is a little more durable for high sulfur environments that we learned in China. Here are our power supplies we're putting together. One of the things I didn't mention yesterday was how strong our power supply system is. We use linear DC external power supplies through a power controller for both the positioner and the FTIR. And like I said before, these cable assemblies, they're all gold coated and have redundancy built into them, and it makes for a very strong system. Over here, we actually have a couple systems that are being repaired. They're actually competitor systems. I used to work for another FTIR company, and some of the overseas clients have preferred to have Kassay maintain their systems. And so I've been doing this for about 6 years, actually maybe even longer. So these are 2 systems that are going to back to Taiwan after I get them serviced. One thing that we're working on, and it probably will not be ready in time, but at some point, maybe within the next 6 months, is a membrane system that is infrared transparent. And we've worked very hard on this so that it protects the corner cubes. And what you see here is this transparent membrane we have, and it would sit in front of the corner cube array. The trick is for this transparent membrane is to make sure that it doesn't interfere with the target chemicals. And so some of the overlapping regions it does, and some of it reduces some of the energy. But we think that it actually is good enough. So that's something that we are hopeful that will allow the cubes to be placed behind this membrane and be fully protected from the atmosphere. Thank you very much for taking the time to watch these videos. I'm very hopeful that Torrance will consider Kassay worthwhile to be your equipment supplier, and we're looking forward to hearing from you soon. Take care.